Continuing on with number 4, we're going to have a square with vertices at plus minus 1, plus minus 1. So we'll have 1, 1, 1, negative 1, negative 1, 1, and negative 1, comma, negative 1. If we were to draw a picture, of course, it would only take a moment to see that each of the 4 quadrants are represented. One up, one to the right, one to the right, one down, and so forth. It only takes a moment to see your side lengths are 2. So the area of this figure is 2 times 2, which is a 4. But we have a shear. We have a shear where the x-coordinates are going to remain fixed, but the y-coordinates are going to be transformed. The image will be 2 times the x-coordinate of the pre-image plus the y-coordinate of the pre-image as well. So looking at it this way, all of our x-coordinates for these ordered pairs are fixed. But what about the y? Well, we can see that y prime is just 2 times x plus y. Very quickly, double your x, add it to y. 2 times 1 is 2, plus 1 is 3. Here we'd get 1 times 2 is 2, but 2 plus negative 1 is just a 1. Negative 1 times 2 is negative 2, plus a 1 is negative 1. And substituting in a negative 1, 2 times negative 1 is negative 2, plus negative 1, you get negative 3. So, what would this figure look like? Well, we might not be surprised to see we're actually going to have a parallelogram. 1 to the right and then up 3 would be right over here. 1 to the right, up 1. 1 to the left, down 1. And 1 to the left, down 3. So you can see we do in fact have a parallelogram. Now this parallelogram, the area of the parallelogram is base times height. Here's my base. My height is the distance between the two bases. Look, between negative 1 comma negative 1 and negative 1 comma negative 3 is a base of 2. You can see that the y-coordinates are 2 steps apart. And likewise, look at the height. The height here would be measured on this perpendicular. Moving from negative 1 to 1, we have a 2. So 2 times 2 is 4. Area is preserved. By the way, we've just talked about number 7 as we have done the area. So yeah, we do have a very different figure, but we have this parallel movement, a shear along the y-axis for this problem, of course, as opposed to the x-axis as the shears we've done previously. Let's quickly take a look at number 5 and see where we're going with that. So number 5, it says with this previous shear of number 4, what happens to the circle? So for number 5, if I were given x prime equals x, y prime equals 2x plus y, let's write that as a matrix transformation. And that can be so incredibly helpful because we're going to solve for x and y. This is really x plus 0y here, so we could say 1 and 0. But look at these coefficients. They can help you out so very, very much. See the 2 and the 1 down there, and just multiplying row by column, you can see where we're headed. Well, obviously we have the circle x squared plus y squared equals 1. This is going to be sheared. We'd like to know what this new equation would be. And we know that that circle, it's going to not have the same appearance. It's no longer going to be a circle. Let's see what we could do to get xy by itself. You're probably going to remember, I hope, that to eliminate this matrix on the right hand side, we're going to multiply both sides by that matrix matrices inverse. And matrix multiplication order matters, of course. So you have to always specify I'm multiplying on the left or I'm multiplying on the right. We'd want to multiply on the left. And you can see on the right side of this equation, an inverse times a matrix, we've mentioned this before, is always the identity matrix. And when you multiply an inverse to the matrix itself, you just get I. It's equivalent to really multiplying by 1 with real numbers, because I times any matrix is going to be that matrix. So we're going to be left just with xy. Now again, to speed this process up, I hope you're going to be able to find this inverse via the TI-89. And you can just type that in so quickly, and it will give it to you, and it can give it to you incredibly fast. What would we find? Well, we get 1, 0, negative 2, 1. So where are we going with this? Well, look, if I multiplied through on this matrix, row by column, 1 times x prime is just x prime, plus 0 times y prime, that wipes out. Negative 2 times x prime, I'd get that, plus 1 times y prime. Look at this. We have incredible help now. We can say x is equal to x prime, and we can say y is equal to negative 2x prime plus y prime. Well, we are investigating what's happening to x squared plus y squared equals 1. And now I can very simply replace y and x with these primes. We have this new equation as a result. By the way, it's very common at this point to even drop the primes to say, look, we have a new equation altogether. We'll have x squared plus, let's expand this all out. Negative 2x squared would be a 4x squared. Double this middle term, you'll get negative 4xy. Y prime squared, or y squared, is just y squared itself. My goodness, x squared and 4x squared will add up to 5x squared. Well, as we'd study conic sections, we would see that this is actually an ellipse. It would be an ellipse that's not opening up with its major axis in a horizontal or a vertical direction, but off on a slant. And that's something kind of interesting. But this circle is the pre-image. Again, we don't have a congruent transformation. We no longer have a circle. We have something very different. However, the area of both the pre-image and the image will be the same. We're going to move on to dealing with a whole combination of transformations. We'll be doing that next. Hopefully you're going to see the work with the inverse of matrices is an incredible skill that's going to help you out a lot. Keep working, and hopefully we'll be all ready at the end of the unit.